Then I'm going to go to the number 4. I'm going to go to 8. That's a terrible sequence. I don't want this. I'm going to say 12, 14, 16, 18, dot, dot, dot. So you guys see the sequence, right? And now you're like, okay, Robert, we know everything about that sequence, right? Everything. Everything. In fact, what's the first term in that sequence? So I'm going to highlight the first terms in green, although that's too much green. So wash it green. That's the first term. You can just look and then decide if there's anything of value here and write it down. Right? I want you to decide if it's valuable or not. Now, I claim this is an arithmetic sequence. If your sequence is arithmetic, you have to be able to take a term, subtract the previous term, and get the same number regardless of the term you pick. So if I take 14 minus 12, I get 2. If I take the third term, 16 minus the second term, notice I'm also getting 2. Same thing with the fourth term minus the third term, I get 2. These are all common, right? They're all the same. In fact, we call this the common what? Factor. Now, what did we do each time? I subtracted. I call it the common difference. So this sequence has a common difference. Its common difference is 2. The common difference is 2. And I'm going to highlight that common difference in, I'll use this yellow color. You can see my common difference. Yeah, I've got my 0 term, I got my common difference 2. Now, if I want to back up from the first term, right, I could find what's called the 0 term. 0. What's the 0 term of this sequence? Yes, sir. 10. It is exactly 10, right? And in order to get that 0th term, all I'm doing is I'm taking the first term and I'm subtracting that common difference. So 12 minus 10, 12 minus 2 gives me the 10. And I'm going to highlight this in blue. This is my common difference. Okay. Now, that's largely all the things that we would ever care about for an arithmetic sequence. What's your first term? What's your common difference? And maybe what's your 0th term? Okay. Now, I have right here in this list really all the information I need to know about it, but I can record this down using two techniques, right? One's called recursive, and the other is called explicit. Recursive, you keep doing something to keep going forward, right? You keep doing the same thing again and again. Explicit, you just tell me, I want the 12th term, and the formula will tell you exactly the 12th term. In the recursive one, if you want the 12th term, you have to know the 11th. And then get to the 11th, you need to know the 10th. Get the 10th, you need to know the 8th. So that's why it recurses back to the beginning. But let's just go ahead and write out what we call our let's do recursive first. Let's do recursive. So recursive. Oh, no, not blue. We're going to write recursive. Recursive. We'll write the recursive definition. Here it is. The recursive definition always begins with, tell me one of the terms, I like the first term. So this is saying the first term is 12. So you can see right here, I used that first term, right? As part of my recursive definition. You start at the number 12, and then I read this next part this way. To get to the next term in the sequence, you simply take the term that you are at, and you add to it the common difference. The common difference could be a negative number, in the case it's decreasing. Here it's positive. So you add to that the common difference. And now you can see here this recursive rule tells me just the first term and then how to move forward. Okay, how do I read this? To get to the next one, take the one that you're at and increase by 2. Right? How do I get to the next one? I take the one I'm at and add 2. Right? You can see how the color coding's happening. Oh, I didn't say you weren't.
I'm slow liquor.
I didn't need 2. Yeah, especially. Yeah. So this is the recursive thing. I'm going to stop there. But now let's take a look at what we call the explicit rule. I'm going to write the explicit rule 2 ways. Only one of them is necessary. So the explicit rule. explicit. It looks like this. To get to any term that you want for an arithmetic sequence, you're going to take the number. You're going to take your common difference and you're going to multiply n by that, and then you're going to add to that your zeroth term. You can see in this formula here, this is my common difference, and this right here is my zeroth term. Okay, and that's done, that works. If that works for you, that's great. Of course, this needs to figure out what the zeroth term is. So that's one thing, right? You need to go backwards to figure out what that is, and this is my common ratio. My common difference. By the way, the reason why I'm using multiplication here is to show that I keep adding 2, you multiply. So if I wanted to add 1 2, it would be 1 times 2. If I wanted to add 2 2, 2. If I wanted to add 3 twice, right? 2 plus 2 plus 2. That's just 2 times 3. See what I'm saying? So this shows repeated addition of the number 2. There's another way we can write this that uses the first term. Some people like this notation better. I see both like often on the internet. So this is another way you can write. This is an alternate definition of the explicit rule. To get to any term you want, you're going to take 2. You're not going to multiply by n. You're going to multiply by n minus 1. But then you get to add the first term instead of adding the zeroth term. So you can see there's some similarities here, right? Both of these are still making use of the common difference, right, of 2. But instead of using the zeroth term, this one's using the first term. And if you think about it for just a minute, you're like, oh, I got that, right? If I want to know the first term in this sequence, what does it do? I want to know the first term. This becomes what? So for the first term, I don't add anything, do I? For the first term, I just 12, the first term, right? And then if I want to know the second term, right, this is saying, okay, this is now going to be just add 1 2. The third term, add 2 twice, right? Because 3 minus 1 is 2. I'm going to add that twice. You see how that works? You can see both of these, right? One is using, this one right here is using the zeroth term. This is using the first term. Other than that, they're the same. Okay. So on that one page, I'm gonna claim that that's everything we need to deal with for an arithmetic sequence. That's all. Okay. You got this down in your notes. If you can commit to this, it's great. Right? Sometimes when you're adding is a negative number, the sequence goes down. But other than that. All right, let's look at it. Now let's go to geometric. You ready? Geometric. I had a sequence picked out for that, but that doesn't really matter. I'll figure it out. So let's now look at, now that we've done, let's look at the geometric sequence. So I'm going to look at, I'll look at 4, 12, 36, dot. What's happening? Multiplication by 3. Correct. So if you look at this, just like finding the common difference, I took a term and I subtracted the term in front of it. If I started doing that here, I can see, well, these are growing by different amounts, right? This is not arithmetic. But if I take a term and I divide it by the term that precedes it, that's a ratio. You see that? 36 over 12 is a ratio. Watch this. 12 over 4 is a ratio. And I want you to notice that these ratios are both, they're both 3 over 1, or they're both 3. Right? These have a common, they have a common ratio. So in a geometric sequence, instead of a common difference, we have a common ratio. Now, if your common ratio is larger than the number 1, this sequence increases. If your common ratio is between 0 and 1, like more than 0 but less than 1, right, it shrinks. If your common ratio is 1, your sequence is very boring. There's a lot of copies of the same number. It doesn't go up or down, it just stays the same. Okay? So that
negative, would it just go negative, positive? It would be like, for example, if it was negative 3.
Yeah.
It would be 4 times negative 3 would be -12. -12 and -3.
Yeah, that's very good. So if you do see that, if you see things flipping like that, where they're positive, negative, right? That's an indication that your common ratio is going to be a negative number. Yeah, right? And play with that, try to get the right thing. Because you're right, if you have an even power, a negative number to an even power will make it positive. I mean, a negative number to an even power is positive, but a negative number to an odd power would be negative. So you'll see it switching back and forth. All right, so what else? Okay, so let's go and write down what we know here. We have our common ratio. Three. We have our zero term. Is the number. What is our zero term? 5. Don't get complicated. Don't give me some crazy. That's all. It's 4 over 3. Right? In order to move forward, we multiply by 3. If I want to go back 1, right? 4 divided by 3. It's not a doesn't do so there by 0. All right, so let's go ahead and write down first of all and I'm going to color code these the same. Okay, did I use green for my 0th term? No, first term. And did I use the yellowish for the common ratio? Yeah, I did. So that was the common difference of the common ratio. I'll make this one blue. Okay. Just to be mildly consistent. All right, so let's look at the explicit rule. No, I did recursive first. So the recursive formula, right, is going to start out similarly. We're going to say that we need to know one of the terms. My term, David is the first. I'll say the first term is the number 4. And I'm going to say, in order to get to another term, you are going to take the term that you know, the term that you're currently at, and you're going to multiply that by the common ratio. And I put it in front for habit. So it's just 3 times the term that you're at. So 3 times the term that you're at gives you the next term in the sequence. And you will have to tell it a term in the sequence. You could very well say the second term is 12. I like to say with the first one. First one is 12. Right? And that is a complete look at the recursive definition of this geometric sequence. Keep multiplying by 3. And the other one, remember, we kept adding to. Up here, on this one, you can see I was adding to each side. On this one, I'm multiplying by 3. All right, so now let's look at our explicit rule. And I'm going to give us the two varieties, the 2 flavors of it. The 2 flavors. The first flavor is going to be based on the 0th term. The 0th term. So T of n, a term in the sequence, is equal to my 0th term, 4/3, times my common ratio raised to the nth power. So when you look at this, right, the mechanism of multiplying by 3 again and again and again is handled with the exponentiation. Right? Exponents represent repeated multiplication. So again, in our color scheme here, the green is the blue is my 0th term, and the yellow is the number that I keep multiplying by. I can do the same thing I did using the first term. If I want to use the first term instead, I can say, well, to get to any term of the sequence, you can take the first term, and you can multiply that by 3, but not to the n, 1 less than n, right? And it does, that has the same magical effect. So if I want to know the first term, right? If I want to know the first term, when I plop a 1 in here, that becomes 1 minus 1, which is the number 0. What is 3 to the 0 power? Don't. Did 1. Yeah. You want to tell the class what you just said?
I said 0.
Yeah, you said 0.
My greatest shame.
It is, truly. Yeah, the 3 to the 0 power is 1. So if I want to know the first term, it's just 4, right? So you can see how that does that. But the advantage of that is some of us might think finding the 0th term is hard. You got to undo the sequence one time, back it up. So if you don't like doing this, this is kind of neat because all you do is you just take the very first term in your sequence, is 4, and you just have to multiply that by the common ratio raised to the n minus 1 power. And I'm smart enough, I can deal with either one of them, right? Either the top explicit one, which is based on the 0th term, or the bottom one, which is based on the first.
What do you mean? I just have this one.
That's fine, you can say goodbye. All right, so that's it. That is my walkthrough / review of sequences, arithmetic and geometric. Arithmetic, adding the same thing again with